Yeah, no worries. Here we have your slides. Gotta make them work for that money.
Oh yeah. Oh yeah.
And then done if you want, like the programs are here.
Yeah.
Like, hopefully it gets a little closer.
Yeah, absolutely.
I'm the clicker, and it shall play. And if not, I'll yell at Jovial and go right up here.
Do you know where judges sit?
It's right here. Reserved.
Okay.
Thanks, Papa.
Are we saving this room for faculty?
Yeah. Faculty, deans.
I said it.
Yeah, absolutely.
Okay.
Yeah.
I'm a recent.
I'm not published the first time. Yes, for the series.
I'm starting next.
Nice.
Right now.
Like, right.
Have been reserved. This is.
Yeah. Do we have a clicker?
I think it was gonna be done right.
Yeah.
On the dot. I guess I'm gonna sit here so I you can bother me and
That's right.
That's what the intricate is faster.
Yeah, he had some question about it. I
It's
know.
in reserve. VIP seating.
No, I think we'll find it. Yeah, I just sit in the Yeah, it's grad school. The bags under my eyes. Yeah, I'm trying to. I had to practice
I love that picture that you sent.
Very sensitive.
But also like
Everyone, so we'll start from the beginning.
I mean, if you're I have the same reaction when I see it.
It's like it can't be. Is that no, there's one here? Okay.
So we dim the light.
I mean,
Alright. like to welcome you all this evening, and I would like to take this opportunity to welcome Dr. Rafat, the Interim Dean of the School of Engineering and Applied Science.
Good afternoon, everyone. I'm Rumana Rifat. As Jonathan said, I'm the Interim Dean of the School of Engineering and Applied Science. It's my pleasure to welcome you here today to our undergraduate award ceremony and the Pelton Design Competition Award ceremony. I'm pleased to welcome our students, their families here too, and this is, of course, a very special week for you, very special occasion. We are very happy to see your children go through all the 4 years. We see them come in as freshmen. And of course, we are very happy to see them graduate and leave. Of course, we do want them to come back and, engage with us, with our students and, as alums. But of course, we are very happy to see them grow as engineers. And today, we'll get a glimpse of how they work on their different projects. We'll get a glimpse of the different types of senior design projects that they have been working on. So you'll get a flavor for what your children have been doing. So we will be presenting some of the awards today. And of course, tomorrow evening, which is the C's graduation ceremony, there'll be some more awards given out at that occasion too. So without further ado, I'll start our ceremonies for today. I'm pleased to introduce our Associate Dean for Undergraduate Studies, Professor Bagi Narahari, who will be the Master of Ceremonies for today. Thank you.
Thank you, Dean Rafat. So welcome to our annual Pelton Prize competition, and then followed by the C's Undergraduate Award ceremony. So as we have a number of people to recognize this evening, we're going to get started first with the Pelton Award for Outstanding Entrepreneurial Senior Project Competition. Dr. Pelton used to be a faculty member here. He endowed this award. Unfortunately, he could not be here today, so he's going to join us by video, not join us, I guess. We have a video from him describing and talking briefly about this competition. So can we play the video, please?
Hello. Sorry I couldn't be with you. I unfortunately am on travel, but my name is Joe Pelton, and I have had the opportunity to have a very interesting 50-year career that's taken me on travel around the world, I think to 80 countries. I worked for the communications satellite and Intelsat, head of strategic policy, for about 20 years, and then I have been teaching for at least another 20 years at a number of universities. I also had the opportunity to start a number of interesting organizations. I helped start the Space and Satellite Professionals International. I helped to start the Arthur C. Clarke Foundation, which is named after the man who first conceived the communication satellites, and also did 2001, the Space Odyssey movie. And I also helped to start the International Space University, where I served as dean and also had the opportunity to serve as chairman of the Board of Trustees. More germane to this exercise today, I served for over 10 years as a research professor at George Washington University and headed a Space and Advanced Communications Research Institute. When I retired, I had a lot of research money actually left over, and I talked to the dean, and we agreed to set up a new award in honor of the best senior project. And that's now called the Pelton Awards. It's called the Pelton Awards not because of my name, but because of a number of forebears who were researchers and inventors. And that included, most notably, Lester Allen Pelton, who invented the so-called Pelton high-pressure water wheel, and then the first hydroelectric generator. You can actually go online and buy a Pelton generator today. Then there was Willis Pelton, who invented the corn-picking machine and was probably one of the very few people to get a patent, U.S. patent from the Oklahoma territories. And then there was my father, who invented, and we don't talk about this as much, the most advanced and fewest moving part parking meters of its time. I hope on my bucket list to contribute to the list of Pelton patents. I tried to set forth the objectives of the Pelton Awards as I see them. They are innovative, inventive, and inspirational thinking, creative and new ideas that are potentially patentable, effective teamwork, new green ideas that can aid the environment, and interdisciplinary cooperation and outside-of-the-box thinking. I have a theory of education that the goal of a teacher should not be just to instill ideas into people's brains and give the students facts to remember. Rather, to give them challenges and new goals to think about so that they are inspired to learn themselves. So I want to wish you all well and hope that everybody who are the winners of the Pelton Awards and everybody in this room will take this challenge seriously and try to get new solutions to the hyper objects that were key to the future of humanity and the future of our small 6 sextillion ton mud ball we call Earth. Good night.
So each department selected one project to compete in the Pelton Prize competition. The selection process was a difficult one, at least that's what the instructors tell me, and they did not pay me to say that. So before we announce the winners and get into the details, I'd like to have each of the department nominees of the Pelton competition present a short elevator pitch to the audience. These presentations are going to be in alphabetical order. So starting with the biomedical engineering department, I'd like to introduce Nathan Campbell, Samantha Horton, Ria Kim, and John Schlein.
So our project was to create a robotic ultrasound system that we used to help physicians monitor and detect cardiac toxicity causing decreased cardiac function in cancer patients while they receive chemotherapy treatment and for the rest of their lives. We used the JACO2 robotic arm and a SynTouch force finger sensor to build a automated movement system and have force feedback.
We also designed a graphical user interface in order to manually control the robot, as well as to save the positions as you take ultrasounds on the patient, and then to start the autonomous session of the robot.
So next, we had to implement an image feedback system, and that began with a convolutional neural network, or CNN. And so this convolutional neural network has to classify images and videos from the ultrasound into good, bad, or maybe. Maybe meaning that the heart is partially within the image, but not entirely. And that would move on to the image feedback, it's the next part of the image feedback mechanism.
The final part of the image feedback mechanism is an algorithm we wrote for repositioning purposes. We wrote it by dividing the ultrasound images up into an 8x8 mesh, 8 rows, 8 columns, and the program analyzes the 8 rows and their intensities, the 8 columns and their intensities, and then box by box the intensities of maybe images, and compares them to average values we calculated of the intensities of good images, and then offers repositioning functions for the robot to follow.
from computer science, I'd like to introduce Dietrich Redenbaugh.
Hi, everyone. Indoor robotics is a quickly growing field expected to reach over $50 billion by 2026. It has some applications in some pretty critical areas, including customer service, patient care, deliveries, security, and anti-terrorism. Robots have been developed for all these areas, but what's lacking is a solution to effectively go between floors in a multi-story building. There are stair climbing robots, but they're pretty expensive and complicated and not the most safe. And it's also possible to have a robot directly integrate with elevator software over the network, but this is not practical in a lot of situations. Instead, we've come up with a solution that allows a robot to use elevators like a human. So how this works is we have software modules that can be added on to an existing robot to allow it to do three things. The first is detecting the elevator buttons, so we can find both the up and down call buttons to request the elevator, and if the robot had a robotic arm, it could push them. And also the floor buttons on board. We're using a combination of computer vision and optical character recognition to identify which buttons are for which floors. We can also determine when the elevator is arriving. Usually an elevator makes 2 dings if it's going down and 1 ding if it's going up. So we can listen for these tones and compare against the background noise to determine when the elevator is coming. Elevators usually make a beep when they pass by each floor. And if we count these beeps, we can figure out when we've reached the correct stop. Finally, if there are multiple elevators to choose from, we are using an array of multiple microphones and comparing the times the sound arrives at each microphone to determine the angle from which the sound is coming. We can correlate these with the angles to each of the elevators to determine which elevator is arriving, and then we know which elevator to board. So that's ERP, the Elevator Robot Project. We're enabling robots to use elevators just like people, and we hope that this will help indoor robotics better meet the demands that society is placing on it. That's my elevator pitch. Thank you.
From electrical and computer engineering, I'd like to introduce Emma Gutzman, Sebastian Velazquez-Fobe, and Brandon Waller.
Let's do this.
Oh, okay. Fair enough. So, there are 4 problems that we would like to address with the auto tracker system. Primarily, we'd like to focus on the cluttered dashboards in cars. Additionally, the lack of data collection and utilization.
Fuel consumption and its use, as well as reckless driving.
So Auto Tracker is a fully integrated vehicle monitoring system that seeks to solve some of these problems or alleviate the effects of them. The way the Auto Tracker works is that it collects data from the onboard diagnostic port within a car, which is an interface for accessing a variety of sensors within the car. Additionally, it has a GPS module that allows you to view the position of a car in real time on a map through our monitoring application. Additionally, through that application, you can help reduce reckless driving by monitoring the driver's behavior so they'll be less likely to drive recklessly. Additionally, to alleviate the issue of cluttered dashboards, we've created our own display using the data we collect that allows you to view the most critical information in a more convenient location with less visual noise or distractions. And thank you. That's Auto Tracker.
From engineering management and systems engineering, I'd like to introduce Jordan Asking, Jacqueline Belfi, Sydney Eskin, and Anya Welch.
Good. We are the EMSE team here to present to you about the creation of our decision support tool. Our decision support tool was created with an understanding that many developing countries do not have reliable energy infrastructures for their healthcare facilities. We focused in a case study most specifically on the country of Nigeria. On the right, you can see a map that we outputted using geographic information systems that shows more than 30,000 healthcare facilities across the country. We came to understand that more than 60% of these facilities are not currently connected to the national energy grid. We wanted to better understand how to supplement this energy demand for healthcare facilities across the country. We began to look at that by using the microgrid-enabled technologies, such as, most specifically, green microgrid-enabled technologies, such as solar panels and wind power. Through different methodologies, such as a directed literature search, geographic information systems, a multi-criteria decision analysis, and the creation of multiple linear programs, we were able to output a decision support tool.
Through the methodologies utilized by the decision support tool, the tool recommended green energy technology implementation for selected facilities. The tool looked at different budget scenario outcomes with varying budget levels and coverage level percentages. These outcomes show the feasibility to NGOs of implementing our decision support tool. And all in all, the decision support tool is applicable to other developing countries and motivates green energy technology implementation since there's an avenue for NGO funding. Thank you very much.
From Mechanical and Aerospace Engineering, I'd like to introduce Michaela Altland, Alexandra Borganti, Matthew Rosenstein, and Noah Thomas.
Hi, so we're the mechanical engineering group. For our project, we made a self-sorting recycling machine. We realized that there's such a problem with recycling. Throughout the US, only about 90% of plastics are actually in the waste, so that's not good. And on GW's campus, 35% of things in the recycling are actually trash. So we want to lower that number. Looking at that, we decided to use Google API Vision technology. So it's basically going backwards with the image and giving us results. So from our current results, we have about 12% contamination rate in our recycling can, which is a lot lower than GW's current one. And as well as in our trash can, we have only about 25% of things in there are recyclable, while GW actually has 50%, which is not good. We would be able to add an additional 500 tons of things would be recycled. Our thing is completely contained and is able to be added onto different recycling cans throughout GW. And that's our project. Thank you so much.
Congratulations to all the teams for being selected to represent their departments. So earlier today, while most of you were enjoying your lunch or hanging out in the lobby at the project showcase or recovering from a hard night's partying, these 5 teams were presenting their projects to a panel of judges. And the elevator pitch you just heard was the culmination of the competition. I'd like to thank our judges, Professor Amadi from Electrical and Computer Engineering, Professor Pablo Frank Pelton from Computer Science, Professor Jason Zara, who's hiding somewhere, from Biomedical Engineering, Professor Erika Grala from Engineering Management and Systems Engineering, and Anna Maria Tandon from the GW Innovation Center. And Professor Karthik Balusu from the Mechanical and Aerospace Engineering. Thank you, Mike. I should stick to the script. I'd like to invite Dean Rifat to the podium to present this year's Pelton Award prizes. We'll start with the 3rd place award. This goes to Jordan Askey, Jacqueline Belfi, Sydney Eskin, and Anya Welch. The team will receive $500 plus an additional $300 because their project has been deemed both green and patentable. The second place award goes to Nathan Campbell, Samantha Horton, Ria Kim, and John Sloan from Biomedical Engineering. The team will receive $1,000 plus an additional $200 because the project has been deemed patentable. And the first place award this year goes to Dietrich Reidenbaugh. Dietrich will receive $800 plus an additional $200. I'm sorry. I was going to pocket the $1,000. Dietrich will receive $1,800 plus an additional $200 because his project has been deemed patentable. Congratulations to all of this year's participants and winners of the Pelton Award competition. So we will now transition to the next portion of our program, the annual SEAS Undergraduate Awards. These awards honor students who have made outstanding contributions and achievements as members of the School of Engineering and Applied Science. I'd like to ask Dean Rifat to join me at the podium to congratulate our award winners. So we begin with 3 awards made to underclassmen. The first prize is the Steve and Shelley Heller Award. This prize is awarded to a woman undergraduate sophomore computer science student that is both academically strong and has demonstrated leadership potential. This year, the Steve and Shelley Heller Award is presented to Sarah Morin. The next prize is the Susan Shin Award. This prize was established in memory of Susan Shin. It is presented to an undergraduate rising senior who exhibits the qualities of compassion and selflessness in mentoring underclassmen. This year, the award is presented to Camille Dazinski. She's not here to receive the award. The third prize in the underclassmen awards is the Tau Beta Pi Outstanding Sophomore Award. This award recognizes a sophomore with the highest grade point average in Cs. The good news is we have a lot of them this year. This year, the Tau Beta Pi Outstanding Sophomore Award goes to Florencia Diane, Grant McLaren, and Joseph Signorelli. Unfortunately, none of them are here to receive the prize.
You mentioned that their exams ended last week.
Yes, I was asked by the dean to explain their absence. Their exams ended last week, so they went home.
They're in the library studying.
Right. So next we move to several senior awards. And we begin with the Best Senior Design project award in each department. Each of our 6 departments select one project to be recognized as the best senior project for their department. We will begin with the Department of Biomedical Engineering. This year, the best senior design project from the BME department was a tie. The first group is the project team for classroom adaptation for a wheelchair. Wheelchair users would benefit from having the ability to sit at any table in a room without having to solicit aid or draw attention. This team built a device featuring 4 linear actuators which raise the table within an 8-inch range as determined by limit switches and are effective 80% of the time, and with a load of up to 280 pounds in under 30 seconds. Please join me in congratulating the following students who were invited to the front to accept the award from the Dean. Elizabeth Dillon, May Khalil, Daniela Rendon, and Danielle Roman. The second team from the BME department is the project team for obstacle avoidance, helping visually impaired individuals navigate the environment. The team designed and built a device to aid visually impaired individuals navigate their environment. It is capable of detecting objects in the user's surroundings, tracking them, and determining their location. Please join me in congratulating the following students who were invited to the front to accept their award from the Dean. Sydney Bales, Aaron Lynch, Elena Martinez, Sarah Melot, Jared Schlossberg. The next project is from the Department of Civil and Environmental Engineering. The best senior design project from the Department of Civil and Environmental Engineering is the team that built MSM headquarters in Los Angeles. MSM headquarters is a 5-story steel frame office building located in LA. It has an average floor area of 30,000, reaches a height of 71 feet. To resist the high seismic actions that are prevalent in LA, the team used moment frames as the main lateral load resisting system, and the design was accomplished using advanced 3D dynamic analysis for the whole structure, resulting in smaller member sizes. Please join me in congratulating the following students who I invite to the front to accept their award. Said El Mohandes, Mario Velazquez, Manuel Ivan Fiole Garcia. The next project to be recognized is from the Department of Computer Science. This particular award is named in honor of Arnold C. Meltzer, a faculty and alumnus of SEAS. The winner of this year's Meltzer Prize for Best Senior Design Project in Computer Science is the team Privex, Extending Your Privacy. With the increasing number of stories in the news about major hacks and large companies misusing personal data, people are becoming increasingly interested in protecting their privacy. A major area where privacy controls for users are extremely lacking is web browser extensions like spelling, grammar checkers, and ad blockers. Privex provides an extension platform that gives users more granular control over how extensions can access and manipulate data. Please join me in congratulating the following students: Samantha Hanna and Nathan Walker. Additionally, the Computer Science Department presents the Gary and Judy Bard Entrepreneurial Award. This prize was endowed by a CS alumnus and is awarded to a project that is deemed the best CS project with an e-commerce focus. This year, the winners of the Gary and Judy Bard Best Entrepreneurial CS project is the team BST, Secure IoT Data. Due to the low computation power of IoT devices, a gateway device such as a mobile phone is often relied upon to communicate to the internet and defend against potential hacks or vulnerabilities during data transfer. However, any compromise in the OS running on the gateway device can render this data vulnerable. BST creates a solution to this by utilizing an isolated, secure operating system known as a trusted environment. Please join me in congratulating students who I invite to the front to accept their award: Devin Kopp and Zhiheng Fan. The next project to be recognized is from the Department of Electrical and Computer Engineering. This particular award is named in honor of Daryl Rolfs, a former faculty member. This year's Daryl Rolfs Best Senior Design Project from the Department of ECE is the team, the Modern Alexa-Controlled Smart Home. This senior design project is a prototype for a smart plug designed to control power to common electrical appliances around the house and measure the power usage of these appliances. The advantage of using a smart plug is the ability to remotely, by using voice control devices on and off, either by manual control or according to a predefined program. Please join me in congratulating the following students: Marie-Laure Brosset, Agam Mittal, and Matthew Taylor. The next project to be recognized is from the Department of Engineering Management and Systems Engineering. This year's award goes to the team Railway Expansion and Resource Coverage Analysis in Nigeria. The Federal Republic of Nigeria has extensive natural resources and significant economic potential, but portions of the population suffer from poverty and lack of access to essential supplies due to geographic isolation. This project constructed a data-driven railway development map to increase the coverage for the resource of interest, vaccines, to remote areas in Nigeria. Please join me in congratulating the following students: Tori Monteleone, Deborah Kropp, Joshua Smith, and Cooper Graver. Next and final senior design project to be recognized is from the Department of Mechanical and Aerospace Engineering. This year's best senior design project goes to the Baja SAE Transmission team. The Baja SAE Transmission Senior Design Project aimed to design, manufacture, and test a lightweight and durable gearbox for the 2019 GW Baja car. The custom transmission design improved acceleration times and top speed, as well as reduced weight by over 57% from the previous gearbox. These improvements led to a result of 20th place out of 100 universities in international competition, highlighted by a 15th place finish in the 4-hour endurance race. Please join me in congratulating the following winners: Andrew Etzenga, Alexander Snowfer, and Connor Gillespie. Congratulations to all of the best senior design project winners. Next, we present several awards that recognize the outstanding performance of our graduating students. The first such award is the Abdel Fattah Abdallah Prize. This prize, endowed by colleagues in memory of a former chair and faculty, is awarded to an electrical and computer engineering or biomedical engineering or computer science student for outstanding scholarship and service to their respective departments. This year, the Abdel Fattah Abdallah Prize is awarded to Sarah Melot from the BME department. The next award is the Norman B. Ames Award. This award is given on behalf of the Engineers Council to seniors who have made significant contributions to the student body, to the School of Engineering and Applied Science, and to the university community. This year, the Norman B. Ames Award is presented to 2 seniors: Sydney Bales from Biomedical Engineering and Nathan Walk from Engineering Management and Systems Engineering. The next award is the Martin Mahler Prize. This prize was established in 1953 as a gift from Martin Mahler. It's presented to the undergraduate, junior, senior, or graduate student who submits the best reports on tests in the materials laboratories class. This year, the Mahler Prize is presented to Ashley Cooper. final award given today is the George Elowitz Prize. This award was established by Robert L. Morris in honor of George Elowitz and is awarded to a graduating senior who demonstrated a broad interest beyond engineering and technical subjects through past and present participation and/or study in the humanities. This year, the George Elowitz Prize is presented to Elizabeth Dillon from Electrical and Computer Engineering. I ask everyone to join me one last time in a round of applause to congratulate all of our awardees and graduates. In closing, I'd like to convey how impressed we all are by your achievements this evening in the past 4 years. I commend you for your dedication, perseverance, hard work. It's not easy, but you guys did it. Right? So you're due for a grand celebration. Make sure you wake up by 4 o'clock in the afternoon tomorrow. Okay? In addition, I'd like to ask each student to stay connected, come and visit, update us on how you're doing. One of our greatest strengths as a close-knit community is our relationship with our alumni. Best in your future personal and professional endeavors. I do have one final question, quiz. You ready to graduate? Yes. I didn't hear it. Are you ready to graduate? Yes. Good. In that case, some quick reminders. Join us for the C's graduation ceremony tomorrow. C's will host a reception from 4 to 6 p.m. in SEH in the first floor lobby and B1 in the green wall right outside. There'll be signs for each department. If you want to meet faculty from your department, go there. If you don't want to meet faculty from that department, go to another. Graduates will begin checking in at 5:45 p.m. in Funger Hall after the senior class picture. And all family members of the graduates should head over to the Smith Center at 6 p.m. The ceremony will begin promptly at 7 p.m. in the Smith Center. Last but not least, join us outside for a reception to celebrate the awards and I guess to get ready for your party later tonight. Right? And do not forget to stop by the C's Alumni and Development Relations table. Okay. Thank you.